lots of reasons to go global and lots of opportunity to go global with a number of different data centers and cloud providers across the globe. Now, if you look at it, there's actually a whole thought process of how you can design an application to make it a global application and what are the characteristics that you want it to achieve. And when you boil it all down, it comes down to a number of these types of design patterns. Well, YugabyteDB is able to support the following 8 design patterns, right? Now, what's interesting is that only 2 of these patterns are really usually done with relational databases. Those are the 2 that are standardly done. And a third one, read replicas, can be achieved, although with a lot of caveats and difficulty, right? So 3 of these can be achieved. 2 of these are stock, most often done. And if you look at what a globally dispersed database like YugabyteDB can do, it can get you to deploy a lot more of these design patterns. Now, that 4 is a lot of design patterns to talk about in the short time we have. So here's what we'll do. We'll actually pick one of these actual application patterns. It's called latency-optimized geo-partitioning. Well, the idea is we will take our TradeX application, which, if you guys remember, we actually migrated from Oracle to Postgres just some time ago. And we've decided we're going to go global with it. We already have DR set up with Xcluster. No problem. Now our ask is we want to make sure that we want users in the East Coast and the West Coast of the US to have low latency while being able to survive a region failure, right? And giving us low latency. Well, we can have it all right now with the global application capabilities. So instead of me explaining, why don't you guys take a look?
Let's see what you described in action. Our trading app has really taken off, and the transaction volume has grown exponentially. It's become a mission-critical app for our business. As a result of this, we have now deployed our database as a single stretched cluster across 4 regions. We've also configured preferred locations for the database data. That's to achieve 2 goals. 1, West Coast users will access their data on the West Coast, and 2, East Coast users will access their data on the East Coast. With this setup, which we call our latency-optimized geo-partitioning deployment pattern, we expect to achieve the magic combination of both great performance under normal operations and resilience with continuous availability and no data loss during regional failure. Let's measure the actual latencies in these situations and see if they meet our expectations. On the left window, you can see our West Coast user. On the right window, you can see our East Coast user. All 4 regions are healthy. Let's make some trades. Our West Coast user loves Google, so let's buy some Google stock. We enter the trade information, and the West Coast user sees 23 milliseconds of latency for the database update operation. Our East Coast user is a big fan of AI and NVIDIA. We enter his trade information. He also sees, quite coincidentally, 23 milliseconds of latency. Now, let's cause some mayhem. Let's trigger a total failure of the database node in the Oregon region. This is a hard failure. Now let's check on our customers who are conducting yet more trades. Our East Coast user still likes NVIDIA. They want to buy even more shares this time. By the way, did you notice that the app is still running, as is the underlying database, despite the outage? Importantly, they're still able to make trades, and this is fantastic. Due to the outage in California, we do expect to see some increased latency for their trade order. That's because the East Coast database is now taking on additional load from the West Coast users. We can see that the latency has increased just slightly to 35 milliseconds. Let's see the impact on our West Coast user. The outage is near them. Importantly, the app is still running with no visible impact. They can buy even more shares of Google, and they can still trade. Despite the regional failure that has taken down part of the database cluster, the YugabyteDB database is still responsive. This is an important point. YugabyteDB offers continuous availability in the face of a regional outage or failure. If any single region fails, the database survives, the app survives, and most importantly, client transactions continue to succeed. We see that the latency has increased to 117 milliseconds because every write operation is now hitting both coasts. It's not a surprise. This is a reasonable trade-off. Every enterprise will choose uptime and zero data loss, even if they have to give up a little bit of performance. To summarize, we've shown something that YugabyteDB leads the industry in offering: the unique combination of great performance under normal operations and continuous availability with zero data loss for transactionally safe and up-to-date reads and writes, even after a total region or data center disaster. All of this happens seamlessly with no add-on solutions and full automation. We're dreaming big and we're going bigger.